Hello, good morning. This is just a continued class of a previous lecture. It's an introduction to analysis of determinate structure. So, in which in previous class we discussed regarding few topics, such as structures and structural forms, geometric classification, types of supports, internal stress and deformations, right? And also equilibrium, compatibility, and boundary conditions. In this particular lecture, I am going to discuss four important topics: linear and nonlinear structural analysis, determinate and indeterminate structures, degree of static indeterminacy or degree of redundancy, and degree of kinematic indeterminacy or degree of freedom. Okay, so I will go one by one. So, what is meant by linear and nonlinear structural analysis? See, in linear structural analysis, the structure should be possess elastic behavior, okay, and obeys Hooke's law of material. What is meant by elastic behavior? Even though after removal of load, it comes to its original state. And what is meant by Hooke's law? Within an elastic limit, stress is directly proportional to strain. Both the thing exist in linear structural analysis, and also the material behavior and load deformation behavior is linear. Okay, most of the analysis we are doing presently using this assumption: the structure must linear within elastic state. Okay, but another form exists, that is non-linear structural state, so in which the most advanced form of analysis can be just doing. Okay, which means, so in which non-linear structural analysis, so which covers the complete loading process from initial stress-free state through the weakly nonlinear behavior under service loading up to strongly nonlinear behavior leading to collapse. Okay, so see, from initial stress-free state to final collapse of the structure, we will go to capture the behavior in nonlinear state of structural analysis. Three types of nonlinearity generally exist, that is material nonlinearity, geometric nonlinearity, and contact nonlinearity. See, material nonlinearity is nothing but any material subjected to load. We are going to study the behavior. There is a stress strain curve we are going to plot. So, using see in figure, I have shown concrete and steel subjected to load. How plot stress versus strain curve to study the material nonlinearity. Similarly, geometric nonlinearity. What is meant by geometric nonlinearity? See, this is a change in geometry of a material. If in geometry matlab length, breadth, depth of any geometrical property, if you are going to apply a load on that particular member, it will change as its geometry, then geometrical nonlinearity will exist. The last one is contact nonlinearity. What is meant by contact nonlinearity? See, you are applying at particular contact area the load. Then what happens? Contact nonlinearity will exist. Once we studied regarding, we discussed regarding nonlinearity of structure. The next topic is determinate and indeterminate structures. This particular topic I just tried to cover in previous slide also. It's very important topic. Here in coming slide I'm going to discuss indeterminacy of the structure, hence it is very required topic here also. So the determinate structure is nothing but the structure which can be analyzed with the help of equations of equilibrium alone, then we termed as determinate structures. So if you consider simply supported beam, this beam is having only two reactions. The available equations of statics are three. So it is easily analyzable. Similarly, cantilever, both are determinate structures. Indeterminate means it cannot be analyzed with the help of equations of equilibrium. It requires extra compatibility conditions to solve. See, in proper cantilever, what happens? Two fixed ends are there. In proper cantilever, one fixity, one simply supported. In fixed, two fixed ends are there. At fixity, three reactions. Here also three. 3 plus 3, 6. But available equations are only 3. Hence, it is statically indeterminate of order 3. Similarly, this cantilever, 4 minus 3, 1. Statically indeterminate of order 1. So, it's a very important question generally asking in VTU examination. Differentiate between statically determinate and statically indeterminate structures for 5 marks. So you generally write 3 to 4 difference. The first one difference is definition. We know that. Okay, the second difference is there is no stresses caused due to changing temperature in case of statically determinate structures. There is stresses are changed due to temperature in case of statically indeterminate structures. There is no stresses caused due to lack of fit in case of statically determinate structures. Stresses are developed due to lack of fit in case of statically indeterminate structures. So examples: simply supported beam, cantilever beam along with three hinged arches, also statically determinate structures. Fixed beam, propped cantilever beam and two hinged arches are statically indeterminate structures. Okay, the next important topic is static indeterminacy or redundancy. See, I'm a few things I'm making clear that if I am talking about statically determinate or statically indeterminate, it is with respect to structure. Okay, if I am talking about static indeterminacy or redundancy, that is with respect to joint of the structures. Okay, it's clear now. The total number of unknown forces in framed structure to be determined during analysis can be classified into two types. Okay, generally there are two forces we are going to consider. One is unknown external support reaction and another is unknown internal member forces. Okay, one is external support reaction and another is within the member internal forces because of application of external forces. Okay, now these are very important definitions. See, the total number of unknown forces which cannot be determined by the equations of equilibrium existing at each joint of the structure. See, I'm talking about the total number of unknown forces which cannot be determined using the equations of equilibrium existing at the each joint of the structure. Joint of the structure is called static indeterminacy and it is denoted by capital I or redundancy. Okay, the total number of unknown external support reaction. See, I am talking about degree of external indeterminacy now. What is the responsible of external thing? There is external support reaction. What is the responsible for internal indeterminacy? That is internal member forces. That is, the concept should be clear because the external forces, that is reactions, right? The internal forces, that is internal indeterminacy. Okay, next, at each joint of the truss and beams we have two equations of equilibrium. See, at each joint, I am talking about joint, we are having two equations of equilibrium. At the truss we are having sigma h equals 0 and sigma v equals 0. At beams we are having sigma v equals 0 and sigma m equals 0. Similarly, at each joint of rigid plane frames we have three equations of equilibrium, that is sigma h equals 0, sigma v equals 0 and sigma m equals 0. Now, for m number of members, unknown internal member forces are, this is unknown internal member forces, m in case of only 1m in case of truss, 2m in case of beam, 3m in case of rigid plane frames. Now, I can easily write an equation for total degree of indeterminacy where m is number of member, r is number of support reactions and j is joint equilibrium condition. Okay, now total indeterminacy is m plus r reaction minus 2j. There are two joint equilibrium conditions in case of truss, hence that is 2j. Here also minus 2j because in beams there are two joint equilibrium conditions, that is I equal 2m, see 2m in case of beams plus r number of reactions minus 2j, two joint equilibrium condition for beams. This is 3m plus r minus 3j, three joint equilibrium condition, three member, 3m, three internal member forces. Therefore, 3m plus r minus 3j. The difference between total indeterminacy and external indeterminacy of the structure is called internal indeterminacy. Yes, that's right. Why? Because the total degree of indeterminacy is nothing but sum of internal indeterminacy plus external indeterminacy. Then what is internal indeterminacy? It is the difference between total indeterminacy to the external indeterminacy, right? The degree of external indeterminacy is given by E equal R minus 2 in case of beams, E equals R minus 3 in case of trusses and rigid frames. Okay. Next, degree of internal indeterminacy is small I, that is given, that can be computed using this equation, total indeterminacy minus external indeterminacy, because we know the equations for internal indeterminacy and external indeterminacy. Okay, when we are coming to problematic part, we can easily understand how these equations are helpful for the computation of indeterminacy. Okay, next, kinematic indeterminacy or degree of freedom. See, this is very simple thing. The total number of unknown independent joint displacement in a structure is called degree of freedom or kinematic indeterminacy. See, say for an example, please consider hinge joint, hinge support. In hinge support, how many reactions are possible? Two reactions are possible. One is vertical and another one is horizontal, right? How many equations or equilibrium are there? Three, right? So if you consider hinge joint, hinge can resist vertical reaction and horizontal reaction because it will resist, because it's having two reactions, but it will allow to rotate, it will allow rotation. Hence, the degree of freedom at hinge joint is 1. Similarly, if you consider fixed support is having three unknown reactions. So it is a rigid support. There is no displacement. Hence, the degree of freedom at fixed support is 0. Clear? So if plane frame structure joint undergoes three types of displacement, two translations and one rotations. Clear? But this is regarding with respect to member. This is with respect to joint. What I explained with the example, that is with respect to joint. When you come to in case of members, be careful. Hence, each member of a plane framed structure can have three types of displacements, namely two rotations and at the end of the member and one translation normal to the axis of the member. These things I am going to explain with the help of sketch, nothing to worry. But in case of joints, two translation, one rotation. But in case of members, two rotations, one translation. Okay, the relative translation of the ends of a member perpendicular to its axis is called sway. I will explain with sketch. Okay, see, the positive directions of various types of displacements and reactions at the end of plane frame structure members shown below. Just observe. AB is a beam having length L. I have considered at both joints three reactions. So it is positive vertical, positive horizontal, positive moment. Similarly, at joint B, just see here. It's very, very important thing. The member subjected to load, there are possible three displacement. That is, what are those? That is two rotations and a translation. What is translation? You just observe here. Initially AB, after what happens if you apply HA, it will move to XA. Because of HB, it will move to XB. It's a relatively equal, XA equal XB. Therefore, it's no sway or any other things. Therefore, it is nullified. But if you consider this horizontal member, because of this one end moment, what happens? It will deflect. A will changes its position to A dash. B changes its position to B dash. Because of this, with respect to baseline, YB is the difference in B dash, and A dash, that is YA. Okay, the change in difference between YB and YA is sway. That is the sway delta. Okay, and also theta A is a slope at A. If you just, it's a slope because of this change in member, right? This is a original member, but initially because of application of rotation, it changes. It's a deformed shape. So this is theta A and theta B are slopes. Theta A and theta B are slope. This is two rotations. If you consider member, two rotations and one translation, that is sway. One translation, that is sway. So generally in members, three displacements, that is two rotation and one translation. In joint, two translation, one rotation. That is very, very important thing. Okay. So in coming classes, I'm going to discuss regarding problems on kinematic indeterminacy as well as static indeterminacy. Okay, if you're having any doubts, don't hesitate to ask. I will clarify your doubts, no problem. If you put an email or you put an inbox. Thank